अरे तो आप गुरुजी तो हो। ये अच्छा, अच्छा उनको बोलते हैं गुरुजी। अ, अच्छा। हाँ, वो हैं। सही है, वो ग्रुप को चला रहे हैं और इतने दिनों से चला रहे हैं। तो लास्ट टाइम जो से आपसे बात हुई, तो लगा अरे 7 साल से चल रहा है ग्रुप। तो हाँ, कितनी एनर्जी, एफर्ट लगा होगा, बहुत सारे अप्स एंड डाउन आए होंगे, फिर भी ग्रुप चलता रहा। ठीक है। हाँ, नहीं वरना ऐसी चीज़ें टाइम बहुत बड़ी बात है। मन तो मूड तो किसी बन जाता है कि चलो पढ़ते हैं, लेकिन कंटिन्यू कब तक करोगे? हाँ, हाँ। अच्छा, तो ये अच्छा और क्या कहते हैं सर कि और इसमें वैसे अगर मैं हाई लेवल पे पूछूँ तो सर क्या-क्या कवर कर चुके हैं इस ग्रुप में 5 साल में कौन-कौन से एरियाज़ कवर करे होंगे मतलब जैसे अगर पूछूँ आई वाई आस्किंग?
तो जब हमने शुरू किया था तो मशीन लर्निंग से शुरू किया था, बहुत बेसिक लेवल की चीज़ों से शुरू किया था,
हाँ,
जिसमें कंप्यूटर को ये सिखाया जाता है कि ये लाल बॉल है, ये नीली बॉल है।
तो ये कौन-सी सन की बात है सर ये?
वही जब शुरू किया था 5-7 साल पहले।
अच्छा तो लर्निंग मशीन लर्निंग उस टाइम पे शुरू करी थी मतलब?
हाँ, उसके
अच्छा।
बाद बेसिक थोड़े बहुत कोडिंग और कुछ कुछ और सब्जेक्ट्स। फिर वो ओराइली वाली किताबों पे आ गए थे। वेलकम
ओह!
मनोज। अब
अभी
बात कर रहे हैं पिछले 5-7 साल में हमने क्या क्या पढ़ा।
सर नमस्कार सर, ये जस्ट आप ही की बात चल रहे थे हम।
हाय राधा, नमस्कार।
आई
कैसे
गो
हैं?
विथ माय नेम मोहन सर, आई गो बाय नेम।
मोहन, अच्छा।
ओके,
ओके।
सर
तो मैं बता रहा था कि हमने पहले मशीन लर्निंग स्टार्ट करी, फिर मशीन लर्निंग साइकिट लर्न और क्या क्या दुनिया भर की चीज़ें पढ़ी। इस बीच में सिस्टम इंजीनियरिंग भी पढ़ी, कोई कोई
हुँ,
और किताबें भी पढ़ी, और इंटरव्यू की तैयारियां भी करी,
हुँ,
यूट्यूब चैनल्स पढ़े,
हुँ,
बहुत
हुँ।
कुछ पढ़ा।
अच्छा, अरे वाह! हुँ, तो सही अच्छा है सर। आप नो लास्ट टाइम व्हेन आई वाज़ टॉकिंग टू यू व्हेन आई वाज़ शोइंग दिस बुक ओरेली बुक स्किटी लर्न राइट दैट टाइम से अरे ये तो बुक पढ़ चुके हैं हम इन दिस ग्रुप में। अब लेकिन अब नाउ अब जो रियली में यूज़ हो रहा है नाउ वी व्हेन माय प्रोजेक्ट वी स्टार्ट यूजिंग इट एंड स्टार्ट मूविंग टू एआई स्लोली स्लोली वी आर मूविंग तब लगता है कि यार ये चीज़ पहले पढ़ लेनी चाहिए क्योंकि अभी इसमें भी तो टाइम लगता है ना पढ़ने में यू कैन नॉट रीड इट ओवरनाइट राइट या सो इट्स रियली गुड अभी तो खैर बिकॉज ऑफ दिस एआई बूम आफ्टर दैट एवरीबॉडी स्टार्ट शोइंग द इंटरेस्ट बट दोज पीपल दे वर लर्निंग प्रीवियसली पुराने सीख रहे हैं तो ऑब्वियसली दे विल हैव द बेटर ग्रिप
तो धीरे धीरे लोग और जुड़ते गए और ये ग्रुप बड़ा होता गया, पर पहले हमारे पास 4-5 ही लोग होते थे और उन्हीं लोगों में हम ग्रुप को चलाए जा रहे थे। और काफ़ी सारी किताबें तो हमने ऐसे ही पढ़ डाली। और जो नए लोग आए उन्होंने, कई बार लोगों ने ये भी पूछा कि भाई हमने तो बहुत सारी बुक्स पढ़ी दी हुई हैं, हम क्या करेंगे, हमें कैचअप कैसे करेंगे। हमने उसका रास्ता यही बताया कि भाई आप जो बुक चल रही है उसे उठा लो, उसे पढ़ना शुरू कर दो, और जो उसमें ना समझ में आए, आपको लगे गैप है कि पहले से हमें आना चाहिए था और हमने पूरा ध्यान नहीं
मिस कर
दिया,
दी ट्रेन ना so I should
तो
not catch that train
उसको अपने आप बैठ के कैचअप कर लो, यही एक रास्ता है।
हाँ राइट राइट ये जैसे ही इफ यू मिस इट देन डज नॉट मीन दैट यू शुड नॉट बोर्ड इट राइट लेट्स मतलब जहां से हो गया वहीं से मतलब ऐसा तो ज्यादातर मोस्टली वी कवर द डेटा साइंस एंड मशीन लर्निंग ओनली और वी कवर सम अदर एरियाज लाइक अदर देन दिस
हाँ, हमने सिस्टम्स इंजीनियरिंग के ऊपर भी बहुत सारी किताबें पढ़ी हैं।
सिस्टम डिजाइन किया है, डेटा इंजीनियरिंग किया है, लाइक इट डिपेंड्स ऑन व्हाट ग्रुप्स इंटरेस्ट इज। शाम ने साइबर सिक्योरिटी के ऊपर भी 1-2 सेशन किए हैं।
अच्छा
तो या so Bobby, I was talking to somebody. He's I think a senior, current senior at HBTI, and I was asking him like, why don't all the current Recordians, why don't they join this kind of call? Like, if if this kind of opportunity was given to us, we would have like jumped on it, right? तो उनका कहना था कि देर इज दिस इम्प्रेशन दैट ओ इस ग्रुप में तो कुछ बड़ा वाईफाई चलता है, हाईफाई चलता है, हमारे शायद काम का नहीं होगा। तो मेरे को लगता है हमने जो है ना थोड़ा सा मार्केटिंग गलत तरीके से कर दिया है। लोगों को लगता है कि पता नहीं यहाँ पे क्या मशीन लर्निंग का क्या इन्वेंट हो रहा है यहाँ पे। We probably
बहुत ज्यादा हो गया सर।
less than what these current students know.
ओहो,
अरे
समझ सकता है।
उसके लिए हम लोगों ने एक प्रयास किया था, संडे सेशन को अलग किया था, उसमें कहा था कि भाई फ्रेश से शुरू कर रहे हैं, आ जाओ। उसमें भी लोगों ने बहुत ज़्यादा इंटरेस्ट नहीं दिखाया। तो
हाँ,
हो सकता है कुछ लोगों के दिमाग में ये रहता हो कि भैया मैं तो टच में नहीं हूँ, कोडिंग नहीं जानता, मशीन लर्निंग मुझे तो कुछ भी नहीं आता, मैं वहाँ जा कर के बेवकूफ़ सा दिखूँगा। लोगों के दिमाग में डाउट्स हो सकते हैं, फियर्स हो सकते हैं। पर अगर आप ये चाह रहे हो कि भाई और 20-25 लोग इस ग्रुप में आ जाएं, तो उसका एक ही रास्ता है कि अपने आप को ऐसे पोजीशन करो कि हम जो है एक सेशन ले रहे हैं जिसमें बिल्कुल फ्रेशर से शुरू करेंगे, और उसमें जो है जितने लोग आ जाएं उनको ये कन्विंस कर दें कि भाई कल से आप आ जाया करो, और आपको हमने फ्रेशर वाली ट्रेनिंग दे दी है, आपका फ्रेशर वाला लेवल पूरा हो चुका है, अब आप हमारे रेगुलर सेशन में आ सकते हो, हम इसी लेवल पे रहेंगे अब आगे। तो उससे जो आने वाले लोग हैं उनको ये नहीं लगेगा कि यार मैं पता नहीं कहाँ, ये तो हाई फाई लोग हैं।
सही है सर।
okay, Deepak, Rakesh are here. We can start now.
दीपक जी आ गए, अब तो स्टार्ट कर ही सकते हैं।
गुरुजी आ गए, गुरुजी आ गए।
चलिए सर फिर स्टार्ट करें।
ओके।
Okay, so for today's topic, today's use case, I will say is the Gmail Smart Compose. So as you know, like this book is about designing ML system for different use cases. So today's we are talking through Gmail Smart Compose. So इसकी जो problem Gmail Smart Compose, as the title clearly says, like when we are typing the email on our Gmail and we have the Gemini Gmail or AI enabled on our Gmail, then we say that it automatically suggests. You write like how are you, then it automatically suggests some extra words like to complete the sentence, how are you doing or where are you going, and something it automatically suggests you. So how that system works in the Gmail, that and how if you in the interview environment they ask you to create this kind of an Gmail Smart Compose or Outlook Smart Compose, what are you gonna do? So what are the components will be gonna be in this whole ML system? That's what we're gonna learn in this chapter, and this should be like for me, like when I go through the chapter, the feeling is that like better is a little technical. If you know something about it, the concept, then you can think of yeah, this is the how things works. But it's very high level in this chapter that I was little scared, like I may not able to present this because it's gonna be go more technical and very deep, but it's not like that. So it's little high level, but yeah, but to understand the concept, the keywords technology, like again the transformer came into the picture, then if you remember how the transformer works, then you will be able to catch up the concept very easily. Else it is just I just take it like this is the transformer model we are using in this system. So that kind of the impression I got by reading this chapter. So starting with that, so interview asked like create a Gmail Smart Compose and tell me how you gonna do it. So as always for the software development, we clear the requirement. So there are some questions we have to ask to the interviewer, like so when we what you need, like what gonna be the performance of the system, what gonna be like other non-function requirements. So that kind of question, it's this chapter try to formalize in the beginning to clarify the requirement. So nothing much special on this question. The only thing that say like when you are designing this ML system, like what language you system support. So that question I think like it's good, like are this gonna drive your design changes also. So let's begin with English, and how the system load gonna be, like how many users gonna use your Gmail system. Then they're talking like they're gonna be like 1.8 billion users. Then they say you don't worry about this interviewer, you just design the system first, we will take care of the performance in later. So this kind of a question. So do you guys have any question that if you ask like, oh, create a smart compose, and then what the first question you gonna ask the interviewer? Any one question that you can think of, just to make the interesting. Else, I'm gonna go
So
further.
okay, so I have one question. Am I audible or is it echoing a bit? So when my
Someone you saying something?
there is
Okay,
something
I will continue.
you can.
Okay, and then
I'm having some
this
problem.
chapter like and this chapter like follow some predefined steps. I think the first chapter they say like whenever we are designing the ML system, ML system designing, then we have to start like, okay, what is the problem that we gonna solve as a ML task. So in this Gmail Smart Compose use case, we are gonna complete a sentence. So this is like we have one input like hi John, I hope. Then we know like what gonna be the answer for the next. You are doing well. So this next text generation to complete a sentence, that's our like a ML task. So how the our ML system gonna complete the sentence. So this is input hi John, I hope. Then complete the sentence. Then you are doing well. So this is the ML task, and then we have to use ML model to achieve this. And they talk about choosing a suitable ML approach. So here on this section, I learned like, okay, so there are different, the AI like ML, there are different machine learning models. So which model we gonna use it? And here it's, I feel like they already in this chapter, they understand, already all the AI stuff and ML stuff. So they start talking about there are two type of the model. One is called RNN and one is called transformer model, which helps to generate the text. So now, so they already know this. So now, but which one we have to pick? Either we go with the recurrent neural network, or either we should go with the transformer based ML model. So then they start comparing what is the advantage and disadvantage between RNN and transformer. So if you go through this grid table where they say like RNN is good for the simple and short sequence type of sentences, while the transformers will work well when you have the long sequence of the sentence and you want to ask to generate the next token or next line or something. So, and there is a limitation on RNN network that it work with the bell with the sequential processing, and while the transformer can do the parallel processing. So like in the previous book reading, we know something like that when we are breaking the one sentence into token, and then the parallel transformer model, I think it start taking the one token, two token, three token in the multiple lines, that I remember. So yeah, so that kind of transformer help in the parallel processing, while the RNN is do the only sequential processing. Okay, so this bit of transformer is like model is very scalable, and application wise RNN is good for the time series kind of modeling. I was reading something about it like RNN is good like in a US like ECG, like you have like your ECG uh, historical record, then you want to generate what gonna be your next heartbeat, that kind of system. RNN works well, but transformers work well like more like a chat GPT kind of thing that they are doing, that they have to generate lots of text. So in this approach, they decided like based on this comparison RNN versus transformer, they say, okay, we will go with the transformer model for our Gmail Smart Compose. They also talk about like transformer do have some complexity because it has to calculate the weight on the tokens when they break the sentence. Like John, I hope if you have any some basic idea of the how the tokenization work on the transformer model or in general in the AI, then they have to decide okay, it's a little more complexity in the transformer model. Okay. And about transformer, there is self-attention mechanism which also increase the complexity in transformer, but self-attention like thing that transformers is famous for, like, and it makes them great also. Anything on that? Any question? Like, if anybody want to jump in on the RNN versus transformer comparison, some useful hint.
No, Shyam, I
Okay,
think
no
we can
questions.
move
Then,
forward.
okay. Then next, like, next step into the ML system design. Okay, we decided, okay, which ML model we gonna work. Then, okay, we decided, okay, transform model architecture we gonna use it. Then again, now we have to think about the training. So before training, we say, okay, what is the data? So we have to get the data, we have to train the model, then we have to start utilizing our ML system. So now we are talking about the data preparation. So in data preparation, yeah.
Yeah, one thing maybe I missed because I don't know if my internet is bad or I could not hear you properly. So in the starting, there was a session where we are gathering the system requirements as well as all those things. That part I don't know whether I missed it or it's being skipped or something, because that depends
No,
on
so right. So in this, like, they are saying, like, when the interviewer asking the candidate, like, okay, create a Gmail Smart Compose ML design for the Gmail Smart Compose system. Then if a candidate has to clear the requirements, so what kind of question is he getting? Like,
yeah, because our
like
design will be based on that requirement, right? Let's say
right. So exactly. So if you have any open question, so because it is like a interview kind of stuff, so they say we should ask, as a candidate, we should ask more open question to make sure, like, we have the right use case or limitation or scope of our system. So we can further. Nothing special on this. Like, so one question like was that, like, which language is our Gmail Smart Compose should support? Like, he said, okay, go with just English. That kind of stuff. And what is gonna be the performance? What is gonna be latency, or that kind of stuff.
Radhamohan has raised a question.
So, sir, actually, whatever these requirement gathering questions were there earlier, I wanted to ask. So now, so just asking, like, then whenever we go to any system design interview questions, not this or any other, so generally they are the on high level. They are some generic questions, right? Okay, generally that you will put it, okay, so that you can set the boundaries and you ask the interviewer. So when you read this book, so just asking, like, when it comes to the system design for the machine learning, this generative, so if we generalize it, right, at least these questions we can ask so that we can set the boundaries. So can you just generalize those questions? Not these questions are specific to this one, okay, but there may be some like a generic question, like at least just ask at least couple of the question we can ask all. So when we are going system design, so at least we
Yeah.
always keep in mind these questions will always come. We should ask the interviewer.
So Mohan, I think we'll get that clarity after we go through 4 or 5 such use cases, right? Let's park this question for for a month or so, and then we'll figure out what kind of common questions we can ask about these like general ML system design questions.
Okay, sure. Thank you, sir. Appreciate it.
Yeah, because even like I will not have any idea like what's, I'm not experienced. So by learning this chapter, we will know, okay, this kind of question could be asked. Like one question you can ask, like a model approach. It's not general question, but like
But
which model we're gonna use,
yeah,
and
I
if
mean
you are
the purpose of these questions is not just for asking question, right? Purpose of this is so that you can actually also start forming a solution. There are multiple ways to solve the same problem, right? Um, uh, you're figuring out which one to choose for the given situation. That's why you're asking those questions.
going forward. So on the data preparation thing, we know, like, we have to gather the data. So like how you gonna get the data? So it is talked into this chapter, like Google or Gmail has, like, they have like like some email database where they have all the users' email. So that kind of data they have now. So before we gonna use that data for training to the model, then they say we have to prepare the data. And data preparation, there are some steps, like we have to do the cleaning and the normalization of the data. Cleaning in the sense like if your emails have some non-English text, then we should not consider them, because that will gonna uh, not good for training, like based of the your resource. Remove some confidential information, remove irrelevant characters like emoji, or remove duplicate data. So these are the like basic I think these are the steps, test cleaning we have to do before we use the data for our training in the model. There could be more steps based on the use case, but these are the steps they mention here. Then normalization, like they say, like if you have to standardize the data, like in the phone number format or SSN format kind of stuff, that you want to use a specific format, then you have to find those text and standardize them in your data. So
Yeah. So
you have raw data, then you.
I want to have a discussion on this text cleaning part. I think this will be the hardest step in this whole problem, right? If you are solving this problem, let's say for Gmail or any email provider, right? How do you remove confidential information? How do you identify that this is confidential information, right? If like if somebody wants to train a model on my, let's say, Gmail account, and then they want to expose that model to be used by anybody publicly, like I would be very uh, worried about, like, I don't know what all information will this model uh, tell to the users, right? Like somebody can start writing anything like, oh, I don't know, like any confidential information, right? Like, oh, my salary is, and maybe it will fill in the blanks because it read something in my emails about that. So any idea like what all, how can uh, we identify confidential information?
So this doesn't tell this chapter how to identify that, but
No, that's what I want to
like
discuss here, right? I mean,
yeah,
this
Yeah,
chapter we all of us read, but
yeah.
so there is one way
Sir, I
to do
didn't
it,
read it,
like
but one of the idea. Sorry, sir. Go ahead. Sorry, Deepak sir, you were saying something.
so one way to identify this to which can extract, because all the confidential information is something, is like an entity, right? Whatever text we are having, so it should belong to some entities, so we can find out the entities. For example, email addresses, right? So email addresses can be easily uh, extracted, and then our email address is like a PIA information, which is personal identifiable information, right? So this has to be either removed or masked, right? So not all the personal information should be removed. Some information we can mask also. Masking means uh, we can put it, but in some format which nobody can extract for whom this information is. I think one example is given here of email address, like they have masked the first means the word before the at the rate, right? So we know that yes, this string represents a email address, and at the same time we do not know to which user this email address belong to. Similarly, we can extract information and we can mask them. Similarly, like based on the, and then we can do our training also, right? So masking is one thing. Other technique we usually use is to remove the information. Suppose there is some confidential information which company explicitly said, yes, this is the information for this company, and very strictly used for this, then our crawler should actually remove instead of masking, right? Because company has declared that this information is very crucial for their company, so we should not use them in the training of the models. So these are the two major techniques which we have used in the previous models. We mask them, and then either we remove them.
yeah, Ashish, you were saying something.
Maybe I didn't read the chapter, but one of the idea was, can we label the emails? 'Cause sometimes we can label the emails confidential hai ya business hai, general business hai, and depending on that, we can exclude those emails from the training.
Yeah, yeah. Okay.
Or
What's your
you
thought?
text
What's your
some.
your thought, Manoj? How
So I
do
was thinking
we?
that it has to go beyond just identifying email addresses, right? Probably like we need to remove all the nouns, right? Because they contain names, they contain like as Deepak was saying, right? Entities, information about entities. What we are learning from these emails is like language. How do people write emails, right? That's what we want model to learn. We don't want model to gain any information about any person or anybody, right? So yeah, probably like we have to go beyond just PII.
Okay.
Right. I just also would like to add here because मैं कुछ पढ़ रहा था तो उसमें embedding का concepts बता रहे थे like how the embedding is done like because it identify like verbs तो taken है take है go है goes है and there are multiple format of verb so basically before generating the tokenization और क्लीनिंग कह सकते हैं उसको डेटा की तो इट आइडेंटिफाई लाइक कि जो सेंटेंस में होता है कि आपको वर्ब्स दे कीप इट सो देयर आर समथिंग दे क्लीन इट अप जो कि सेंटेंस में ज़रूरत नहीं होती है लाइक एम्बेडिंग के लिए है बट अगेन आई थिंक सेम कॉन्सेप्ट हेयर अप्लाई एज वेल बिकॉज इफ इट कैन आइडेंटिफाई कि वर्ब क्या है और उसकी मतलब दे डजंट नीड ऑल फॉर्म ऑफ वर्ब्स so repetition they removes like and they only identify the vocabulary so they create the vocabulary from the paragraph so how many distinct words is being used so that's how I think it basically uh, understand the text and yeah
Yeah.
parse the text first and then create some um, mapping there so I
Mhm.
think we can yeah go into deep as well yeah.
Go ahead, Shiva. You want to say something?
Yeah, so I wanted to say that this they when you see look at the requirements, it's already said that the database data set is given. So if it, data set formation is a very difficult and complex topic. So are we discussing that or are we discussing this question is my question.
So data set given is like Gmail is giving you there are all the emails of the users, right? But you still need to prepare that data set.
No, you are not preparing the data set in this question.
Okay. I thought that this text cleaning was part of that preparation.
Just the text cleaning, but oh,
Okay.
okay. Okay, no, I got it. I got it. You're saying that you the cleaning portion, you are asking detailed question, what you'll do.
Yeah, I mean, they said it seems like hand waving saying that or remove confidential information. But how do we even identify what all confidential information is there? Because sometimes the this information is not just like as easy to identify like phone number, credit card, email address that follow the right format, but sometimes could be hidden in the sentences also, right? So but yeah, I see like people have uh, pointed multiple solutions, identifying identities and masking those entities. That could be probably a solution.
Yeah. Okay.
Yeah, yeah, good question.
Hey,
Well, sir.
one more question I have is maybe
Okay.
it's 8:30 anyway. So the thing is, let's say somebody is writing an email, right? So when we're preparing this data, is it context of, let's say I am writing in my email, my context is a little different. I always write like this pattern. Will it suggest with respect to my pattern, or because many people are writing email, it will suggest the next one? Is there any requirement? I didn't see like that kind of requirement, but
So they clarified in the beginning that
So this,
they don't want it to be
yeah.
personalized.
oh, okay. So it's common basically.
Mhm.
Okay, going further. Okay, now you have the data, your text, your then the text to understand for the model, like we have to tokenize that. So now this text tokenization and token indexing mechanism kicks in. So like if a sentence, because the machines understand the number, so we have to convert this sentence, hi, I am Emily, or to that we have to tokenize these words, and those words should be become integers, and those integers should be indexed, so that that kind of thing. So then they talk about like what there is a different mechanism for the tokenization. So we can do the tokenization based either as a character level tokenization, word level tokenization, or sub-word level tokenization. So let's say like let's go to NYC, or you can split this whole sentence to L, E, T, and S like that. Character level, understand word level, like let's go to, let's is one word, go is one word. That kind of you can assign tokens, like split them into token. Every word is a token. And then we have the subword where they say like, okay, the let's, in this let's word, you say like a let is one token and the S is another token. So that will, and then they say like, okay, how it's gonna help? So which one is better mechanism? So I think they have this, I'm not, yeah. So they compare like which one is gonna work well, like, so they say like with the character level, your vocab gonna be like big, and and you will not get any meaningful meanings from those vocabulary, while the word level tokenization give you that large vocabulary and give the meaning, but your vocab gonna be grow very big. So then they say, okay, the subword level is gonna help you to reduce the vocabulary, and this is gonna like less intensive for your training and the management of your like tokens and index. So for the Gmail compose, they say they said that we go for the subword level tokenization, and there is like some ready-made libraries which use this tokenizing mechanism, like they are saying something byte pair encoding and sentence piece encoding offered by Gemini or GPT. So we can use those kind of libraries to create tokens on the data. And so this is like a very much summary of this tokenizing mechanism. But any question on the tokenization, like you want to discuss, like why we go sub word level, just ask any question or discuss, and else I move to next. Okay, no question. So I will go. So once you have the tokens based on your sentences, then those tokens should be indexed. Okay, I believe the index for the searching. And so every token is converted to the numbers, and then numbers. Okay, just indexing. They are doing nothing special. Okay. So yeah, token convert to the numbers, and number they will be indexed to for retrieval. So that's a token indexing. Next, now they jump on like, so we have token. Now they are talking the next step for the machine learning design system is the model development. And so as we in the beginning they say we are gonna use the model development model architecture, that we are going to use a transformer. So then now they started discussing what are the internal of the transformer. There are 3 types of transformer models: encoder only, decoder only, and encoder and decoder. What encoder does, like they say encoder works well like where we have to identify some kind, we have to do the classification from your sentence, like one example, like I am happy. So now if you want to judge the there is echo coming, like it's from me.
Yeah, Mayank, I think you have to.
Bobby needs to go on mute.
Okay. So I like so encoder only model works well for the classification kind of system, like maybe I will say like a Gmail, where we say is spam or not. Maybe there the encoder may work, or the like sentence like I am happy, then you say okay, this is like a good mood or a bad mood. That kind of classification based on your syntax, where this encoder only model transform model helps. Then they talk about decoder only, where the decoders transform model generate the next text, like I hope you are now good, healthy, bad, or sick. That kind of generation of the next token on text, that part of the decoder only transform model. And the encoder and decoder model of the transformer they mention the example where I am graduating and that encoder does here, and then you have to translate the I am graduating to the Japanese language. Then they say like you have to use encoder only and decoder only transform model. So I didn't very much clear about the encoder decoder part, how this works well here. But in the Gmail smart Gmail Compose, it's very intuitive. Like maybe we have to go with the decoder only because we are generating the new text. We have to complete the text, so we will go with the decoder only transformer model, not the encoder. So now then they will go further in the transformer model. What other stuff transformer model contains? So the decoder only transformer consists of the following components: text embedding, positioning, encoding, transformer, prediction head. Okay, so these are internal of the transformer. That on the text embedding, if you like somebody was talking, Siva was talking about, someone talking about the already embedding stuff. So every token has to be converted into the embeddings. Advantage of embedding this is like embeddings create the contains the context. I mean, like example they have give here, like joyful, happy, these kind of tokens, they should live into the same space because they are related to each other. Sad, angry, they should be related to each other. So this kind of distribution of the tokens and the meaning to those tokens, they should be understandable by the transform model. So they use the embeddings, and embeddings help to contain this information some way, like, and if embeddings would have not done help this done this kind of stuff, like then we face the problem of the sparsity. Like we don't understand like what is this token all about, what the token's actual meaning, and so we use embeddings to remove these problems like sparsity and the lack of semantic information. So I think like many of them already aware of what is embedding. Any question on the embeddings? General topic, like so. Next step, they are talking about the what is position encoding into the transformer model. I'm not very much new about this, but position encoding, like they were talking about, that's like I am home. Like so, this whole sentence make a sense, and if they are coming into the same sequence, like I am home, like if the am, you say like home I am, doesn't make any sense. So I think that to make the sentence the whole token or the sequence of the word, to make it very meaningful, they carry the meaning if they are put on particular position. So that's why I think like the positional encoding they are talking about. So every token or embedding, this should also carry a one positional information with them, and that's why they are talking about the positional encoding. So that's why I understood. Anything else? Someone else had some different meaning on the position encoding, just or embeddings. Just to discuss.
I have a question which is very different in nature. Our YouTube live channel, which is being telecasted right now, has a comment. Where can I find a PDF version of this book? It's a live channel, so person is not here probably. Live telecast has incurred a question.
Yeah, I mean, like we have to purchase this book,
Okay,
from the Amazon.
thank you.
Mhm. Okay, so on the position encoding, they said like the position encoding is done by two techniques. One is called fixed position encoding, another is called learned position encoding. Is a little more technical, not very much my area of strength. So in the fixed position, they say they use some sine cosine functions to derive the encoding of the tokens. And learned position encoding, they say they use the learned position encoding used during the training time. I'm not very sure how that concept works, but there are some pros and cons, like when we are deciding which encoding we should use. That kind of question I think we should ask when we are designing the system. Fixed encoding have some pros, like they efficient and support for long sequence. Right, it's a disadvantage, like it has limits, predefined limits, and in is not good. So now we have to, based on our requirement, we have to think which one we should go. Going further, again, like position encoding, they give you a very good performance, but they are efficient. Why? Require additional parameters. Okay, so during the training they require additional parameters that could be inefficient, and lack of generalization. Overfit. Okay, so they are saying like it may overfit to a specific length during the training. So that is a limitation, or the for the learn position coding. But for this case, for the Gmail Smart Compose, they say they're gonna go with the fixed position encoding due to its efficiency and better generalization. So on the generalization, any comment? What the generalization they want to say? I think I read something. I don't remember.
So Sham, I think they're going in the internal details of the what LLMs. How would you like? What would happen if you fine tune an LLM, right? I don't know. It's good for us to understand, but I don't think we'll be dealing with all of this directly.
Okay. That's good.
What do you think? Like, that's the impression I got.
Yeah, like that's right. These are like a very implementation of a transform model. But
I
do
guess
you
this
think that
is,
in the interview they will ask like this?
Yeah.
Okay, why this is better when?
Yeah,
yeah,
that's
it
true.
Maybe.
depends, right? I mean, if we are going deep into building those LLMs from scratch, right? That's where this kind of information is helpful. But if you're thinking
Yeah,
just to use their models, then I don't think so.
yeah.
Okay. Good. And then further they goes to the, again they are talking about more about transformer. Like this diagram is like how the transformers layers are there. Like there is a input sequence which is there is a sentence coming, then you have a multi-head head attention layer, feed forward attention layer, and ultimately we'll get some output sequence by going through this transformer. Again, they are talking about the what is multi-head attention, what is feed forward. I have no idea. Yeah. Going further, then there is something called prediction head into the transform model. This like so this diagram will make like more very give idea something how I convert to that embedding, then will come to picture, then transformer part will do some processing like using the feed forward multi-headers and whatever. Then the prediction heads comes. So prediction heads, what it does, like whatever token is generating, and those tokens generated by the model, it assign them the probabilities. So with the so which should be the next token? How after R what should come? Which token should come? How are you, Zebra or Able? Like that on those next one, I think it assign the probability. That's the work of the prediction head. And I mean, based on those probability, we're gonna pick up. I'm gonna pick up okay, which token we should be put into the next after the hour. That's the prediction head. Then comes the part of the training. I think already we discussed some part of the training. So lack of. So they're saying like how to decide how we should train our model. Like either we should train our model directly through the whatever the Gmail millions of Gmails data we have, or we should think of different approach. So they say like if you just directly training your data using the email data, then your model maybe do the this kind of it will be more it will be overfit, and you may not have the right kind of data to generate the text. So they propose like better we should go with two-stage approach. Like first we do the pre-train the model with general data. General data means like they train the model with your all the data from the internet or books or something. Then once you do that kind of pre-training on your model, then fine-tune that model based on your email data. So this will give you the better result instead of just using the email data to train your model. Any comment on this one? Thank you. Any further? Okay. So pre-training happening here. and this is ML objective and loss function. This is about like whatever the token is getting generated, which token should be picked, and how we do that. So for that, they use this called loss function. So loss function, what it does, like it convert all the probabilities of the tokens into like 0 1 type of thing. So like if the one is assigned to one of the token, then you're gonna use that token for your next. You pick that token for the as a next token. So they perform the loss function on the output tokens probabilities. So this is the loss function. I don't know much about the cross intervention they're talking about on this section, but yeah, but just to make more generalized, like dealing with this 0.02, 0.1 is more difficult than just dealing with 0, 1, 1, 0 like that. So that's the diagram there with more things clear. Like loss function will convert this probability to 0, 0, 1, 1 with the higher probability 1. This token will be picked. Okay, going further. And this is like showing the parallelism by the transform model, where it is doing the same thing. Loss is going on the other tokens. Okay, next. Then comes fine tuning. On the fine tuning, they say like doing the fine tuning of the model based on your just email data. And the only difference they mention on this email data fine tuning, they say like your loss function should run on your email data. I didn't understand what they really mean, but I can say like now once you have the generic trained data, then you will now your model will be knowing more like how the email is written, what the email contains, subject, sender, form, all those things, information will gonna come through your email data. Earlier the data that model was trained, it doesn't understand okay whether this is email, whether this is a book or whether it's an article. But now with this email fine tuning, your model will understand what is email and how the email is written in the text. Okay, so further that this one combining various input. I didn't understand like what is this combining various input they were really talking about. Like into ML, we know like every when you are training the AI model with your data, then data should be like pre-processed and you convert to the feature. That kind of thing happens. We know that. But in the Gen AI era, they are saying like when you are bringing your input data, then you are doing some prompt engineering. But I don't know why they brought the prompt engineering in this Gmail concept, smart compose, because we are not typing something like ChatGPT thing. But what they're saying, the prompt engineering means like they are saying like when you giving input to your model, you give a one prompt template, like means like you will define a particular structure, and in the structure you will have like a specific format, and so that your model know okay the every time the input is coming, it's coming in particular format, and it will gonna generate the response on based on the input formats. So here they give the example, like even like in your one of the email doesn't have the subject etc, but still able to understand okay what this inputs. So this is the fine tune, and they are talking about the two stages of staining, advantage of the two stage staining, like adaptivity, input generation, fast fine tuning, handling data scarcity, mitigating overfitting, resource optimization. Yeah, like these could be like your like points when we are designing the systems. Yeah, so that helps why we are using two steps training. Then they comes to the next step, like in the transformer, something called sampling. Okay, and I understood with the sampling in this manner, like so. What I understood of this sampling meanings, like so when we are generating the token, the transformer is generating the tokens like how. So we have the next token after how is coming R, it can come or do, and they have the probabilities. Now which one we gonna pick? that's something I understood, like they are mean to sampling. So which token we gonna pick, that comes general term is sampling. So there's two type of sampling they are telling. There is a one stochastic sampling and one is called deterministic sampling. Deterministic sampling, they means like you have like a fixed rule, like okay, after the whatever the token generated after the generated, and we will pick the token with the highest probability. That's it. So that's very deterministic or greedy approach. In the stochastic, they say you pick random token with the random probability. So it's not always going to be like after how you can also pick 0.14 token with the 0.14 probability. That's come how come. So then they discuss like what is the advantage between the deterministic approach and the stochastic approach. With the deterministic approach, you will get the fixed type of the flavor, like you say, like when you are generating your email content, it may be like coming with a particular type of the text only, like a theme will be like they give this example, like you see, I enjoy walking with my cute dog, but I am not sure. So this kind of like a particular style of writing can come with your uh, deterministic sampling. But if you want to generate very creative text, or it should have some humor or different kind of your writing style, then you may go with the stochastic sampling. So in this case, they were talking like for the Gmail compose, we don't want to be very creative in the your email writing. So they will go with the deterministic approach, but that they call greedy search. So they're gonna talk about that further. Okay. So there are like benefits and pros and cons between the both approach. So based on your style or your system requirement, we have to pick which approach we have to pick. So they will talk about here. Okay, and next, so in the deterministic approach, there are two type of techniques: greedy search and the beam search. I think greedy search it talks about it will take the next token with the highest probability. In the beam search, there's a different algorithm. They say like they call top k most probable sequence. Means like giving this example, they will pick best three, like top k. I will say okay, top three, pick top three token, and in that, so after how you pick the top three tokens, and again you will try to pick the from the each next token, you again pick the top three, and then you will pick on those last token, you will pick the, they say like you will derive the cumulative probability, and based on that cumulative probability you will take the one path which give you the next token. So that's the how the beam search they will describe, like they say initialization, expansion, and pruning. In the pruning they will say okay, take the cumulative probabilities of the each path and pick the best one. So maybe this algorithm could be like configurable, and they have to decide like based on our output, what output we are getting, and those parameters we can tweak it. So in this case, I think which one they pick. Beam search. Forgot. Yeah. So they recommended beam search for the Gmail Smart Compose system for here. Okay. Then next step, evaluation in our ML, like we have to evaluate how our system behaving. So two evaluation techniques they tell us. One is called offline evaluation, and then one is called online evaluation. Offline evaluation metrics talk about like what I understood from this text. There are two techniques: perplexity and exact match. I don't want to go this formula. I didn't understand that well, but I will go with this diagram, which give you some better idea what they're talking about the perplexity. So I think they are talking about here like when you generating the tokens, or then you're completing the sentence, whatever output you are getting, whether the output is very much good, like makes sense, is good, is accurate or not. So correctness or accuracy they are talking of here, and how they judge, like they have like your input sentence, how are you doing, and if your model, then they see like because we do the tokenization in the ML design. So after how your model should predict R, then how R after model you should predict U. So they are going internally and checking, okay, after how R U. So the probability of U is, what is the probability of the U? So it is 0.56, for the R 0.28. So they will check these probabilities in this perplexity techniques, and based on the techniques, okay, if you are getting the right kind of value, then they say, okay, your model is generating a accurate text or your outputs. So this is one techniques they use, perplexity. Or in the exact match techniques, what I understood, this example, okay, so they, as Bert said, like exact match, like they will gonna compare exactly the tokens. I just got what time, certain input that you give your model. Prediction is was your appointment, and the ground truth. Okay, yeah. So you should have a ground truth sentence to compare with the result. So our ground truth say was your appointment today, and our model is generating the prediction was your appointment, and we see like it is quite matching. So yeah, exact match for the 3 token come yes. In this line, it was nice. Model says meeting you today, but you are expecting seeing you today, so it is doesn't match. So it says no. So I think like exact match, that way they will evaluate your model credibility or correctness, whether your model is generating the right text or not. So these two type of evaluation techniques they referred here, and they say there are other value or row. That's something we can go further maybe in the next chapter. So that's what I learned about the perplexity and exact match in this diagram. Then they talk about the online evaluation metrics. On online evaluation metric, I think this is like your end user experience kind of thing they are talking, like whether you are getting the fast response for your Gmail, when you are typing, you are getting the quickly, you are able to get the suggestion or not, and your latency, your quality, overall your what do you say, user engagement metrics. They were talking about whether you are user liking your suggestion or not. Effective metrics, average completion time. Okay, so I mean these are like your overall how your system gonna perform, like whether user gonna use your system or this Gmail Smart Compose based on experience. Or to measure those kind of metrics, they are suggested these kind of uh, steps, like what we should look for. Maybe the metrics can go more than these, but these are just examples ones. So whether latency, we know that it should be fast. Effectiveness, I mean like whether Gmail Smart Compose system we gonna complete our email writing very fast or not, or it is still taking a long time. So that kind we gonna like whether you are getting better result or experience or not from your Gmail Smart Compose system. So we have to measure those kind of metrics, and based on that we say, okay, system gonna be successful or not. Okay, then finally becomes overall ML system design. So combine everything, the workflow or your steps. They come up with the, yeah. If you see this diagram, like say, okay, so if you say like if you sum up like how your ML system design should work in a very high level, they say like you should have we should have one trigger service, then the phrase generator, then the post processing. I mean, inside that we have in the phrase generator, we have our transformer or our ML system working here. And trigger service is nothing but like when you type something, then your API call should work to go to the ML system, which generate you the next phrase, and then which generate to give you the next suggestion. On those next suggestion, I think you may do some more filtering, like your model generating some kind of text which has some bias or some offensive that you want to block that. So that kind of filtering that you can do uh, inside that overall in your phrase generator steps, and then you will pass that filtered text to your post processing step. In the post processing, I think they mention, okay, again doing some more text validation there, like pronouns replacement, gender neutral word replacement, not safe work. So maybe like content filtering they are doing. So based on your rules, your what kind of like language should be allowed in your final output. Those steps in the post processing that you can take it, and then ultimately then you can get the right next sentence, that next sequence of the words that gonna complete your sentence. I hope you are doing well. So yeah, so these are the like overall at high level view that they are summing up, like how your ML design system will work, how your Gmail Smart Compose ML design system looks overall. That's it, I think. Okay, then they talk all the other talking points. Maybe for the next, we will understand what else can be happen in your system. But I have not gone through them because this was more than enough for me. Okay, any comment? What we have to go further is what we have to learn. Like okay, because we learn okay so much thing. For me, the output of this reading, reading through this chapter. Okay, this is how the Gmail system, smart compose system will work. But these are on the technical way, like okay, but still I don't know. Like if you can say okay, at the end user, if somebody would have be asked somebody ask me okay, how you compose the Gmail smart compose, I would have said the same thing. Okay, I will use one transform model, it will generate text, and I will show it. I don't know, but still they get this 30-page chapter. But we learn, I think it is still more about the AI learning, machine learning that we have to learn. But the overall design wise, yeah, understand we got some learning.
So, what are we doing next week? Can you hear me?
Next week, like you go next chapter, or maybe spill over any question we get from this based on this learning. Maybe next chapter will be like more interesting. More question will come.
Okay, so we will continue the same book, next chapter next week.
Yeah, Google Translate. Next use case. Any question from the audience, like how they want to go through this reading of these chapters? Because as I say, like this is like a very concise information in this chapter. So any improvement that we can make for this book reading, just tell us
Sir,
so that
sir,
based on this we prepare.
from my side, sir, I want to say that you really cover very well and really appreciate your effort. One thing we learn after this book and after this presentation that these whatever the concept at the down they are saying, summarize on where the diagram is there. That's what they mention it. So look like all the machine
Mhm.
learning concept those we need to learn. This is the one main heart of the chapter. I will say it
Yeah,
right. All these concepts are there.
yeah,
So it's good that we will go through each and every one and learn them the detail. And for the next subsequent chapter, I believe all these concepts are going to repeat. They will not be new, but so that we can deep dive in those, and it will be easy to understand and learn in the subsequent
okay,
chapters.
makes sense. Agree.
And one more thing we learned, like when we do system design, we need to design actually a model. It is not like you just take the model and you just tell them. No, we need to tell them the approach as well, that how you are going to design the model from data to cleaning, fine tuning, everything. It is covering all the machine learning concepts with this one.
Yeah.
Yeah. Okay,
Yeah.
thank you.